All right, new day, new laptop to repair. This time we have a Dell XPS 15. This is the 9510 edition, so it'd be a 2021 version. 15-inch laptop. The customer says motherboard replace or repair. So I'm not really sure what's going on with this. I'm assuming it doesn't turn on. I haven't taken a look at it yet. So let's see if we can figure this out together. All right, first thing we'll do is we'll try turning it on. And I don't see any lights. Let's plug in a charger into it. All right, so it looks like we're getting the 20 volt negotiation. The way a USB-C charger works is it starts out at 5 volts and then negotiates 20 volts with the laptop. So we know that the the PD controller is working, and so that's just one less thing. But what we're looking at here is it's pulling 0.02 amps, so we know that most likely the EC chip's coming on. Let's hit the power button and see if it pulls any current. Okay, it's not doing anything when we hit the power button. So this thing's completely dead. That means we're gonna have to open it up and figure out what's going on. And we may have a shorted component, or we may have something else going on. So let's take a look. All right, I'm gonna try to get this bottom off. Sometimes these bottoms are very hard to get off. We just gotta get a plastic scribe into the crack here. And the easier this is to get off, the more likely that somebody has actually been in here. And so it is coming off pretty easy. I bet that someone has opened this up at some point. So I don't know if this has been in another repair shop. Sometimes people send me the repair after it's been at another repair shop. All right, and the bottom is off. All right, let's take a look around. We can see we got the main battery here, has a serial number on it, which means it's OEM. That's just like we specialize in Dell and Alienware laptop exclusively, and all the parts that we sell are going to be the OEM parts. So anything you get from us is going to have a serial number on it. So that's an important thing to look for. Here's the NVMe drive, a couple sticks of memory, and then we got some fans here. Fans look a little bit dusty, but not too bad. Okay, let's go ahead and get under the microscope and take some measurements. Okay, the USB-C charger plugs in here, and then it's going to come through here. This is the PD controller, or the power delivery chip, and that's what negotiates the 20 volts with the charger. And then it's going to output to one of these two chips. There's two of these chips, one for each port. And so we just want to measure the output of those to make sure that we're getting the 20 volts that's going to be going to the motherboard. And we have our 20 volts here. Okay, so now that 20 volts is going to come down over here, and this is where the main power rail is produced. And so on one side of this chip, we're going to have 20 volts. We do. And on the other side, we should have 12.6, and we only have 6.3. Okay, when I see things like this, the chip that's responsible for creating that 12.6 is called is the power management controller chip, and that's what pulses the gate pin here. So we have the way a MOSFET works is just a switch, so it's either on or off. So all four of these pins have 20 volts on it, and then we have the 3 pins on the output, and then this is the gate pin, which is being pulsed, and it should be producing 12.6 volts, and it's only putting 6.3 volts on here, and that's why we only have 6.3 volts on the output here. There is a chance that these two are shorted together, so we can measure that and see the difference, see if we have a difference in voltage. And so we got 0.06, so they're not shorted together. If they were shorted together, it'd be 0. So most likely this chip is not shorted. We can come over here and measure. So this is the 6 volts also, and then this is we have 12.6 here. Here's the battery. The battery comes over here. This is the battery voltage on this side, 11.3, and on this side will be 12.6, and then that comes through a current sense resistor, and then that powers the motherboard. So since we do have 12.6 here, but we only have 6.25 here, there is a chance that we just have a bad power management controller chip, which is actually located on the other side of the motherboard. So we'll have to pull this motherboard out. And so let's go ahead and do that, and then we can continue testing. All right, the motherboard is out. So now we can take a look at this power management controller chip. Okay, so here was that circuit we were looking at earlier. The power management chip's right on the other side of the board. It's going to be located right here. Let's take a closer look under the microscope. All right, here's the power management chip here. And so this is what's responsible for producing the main power rail, and also it runs the protection circuit on this motherboard. So there's MOSFETs that are on the input, and it also handles the charging too. So this thing does quite a few things. It's super important, and they do go out over a period of time from heat and things like that. So let's go ahead and take some measurements right here and make sure that all this looks normal, but it may just, I have new ones of these and we can just change this out. All right, I'm just gonna plug in the charger and then we can just take some measurements. This should be 20 volts right here. This should be 20 volts right there. I think this should be 3.7. 5 volts, that's the enable. That's the 3.7. And then these should be all 3.3, I believe. 3.4. Yeah, so all that looks normal. And then this is going to be the outputs. So we only have 6 volts on the output here. And 11.48, that's battery voltage. This should be 5 volts higher on both of these, or 6 volts higher. So we're missing 6 volts in here. I've seen this before on other ones of these boards, and it just ends up being a bad power management chip. So let's just go ahead and jump straight to that and get that replaced. And if that's not it, then we're going to have to kind of investigate and figure out if it's going to be like a MOSFET or something like that that's causing it, or we have a shorted component somewhere else that we're not aware of. So, but I'm going to start with that because that's going to be the easiest and quickest thing to do. We're going to get this one removed, and then I can put a new one on. All right, we got it off. Let's prep the pads real quick and then I'll get a new one installed. All right, here you go. Let's grab a new one. All right, pin 1's right here. That's pin 1 dot right there. All right, we got the new chip installed. Let's clean up these solder joints real quick. All right, that looks good. All right, so the new power management controller is installed. Let's get this cleaned up and then we can test. All right, so what we're looking for here is when we plug in the charger, we're going to measure right here on this coil, and we should see the main power rails voltage, which is 12.6. So I plugged in the charger, and we'll measure here, and we're still getting the exact same voltage, 6.48. So that means that we have a different fault here that's causing this issue, and we're going to have to keep looking around. It is getting late in the day, so I'll come back tomorrow and we'll continue testing. All right, it's the next day. It was a little late last night to continue, so we're going to continue on this machine here. So last thing we did was changed out the power management chip. But what I want to see is, I want to look at that signal that's coming from the power management chip here. All right, so I'm going to pull up my oscilloscope here. I don't use it very often, but this will allow me to at least see what signals being sent to that MOSFET from the power management chip. And it might give me a better idea of what's going on, because I'm still kind of in the dark on why we have such a lower voltage there. So we'll plug this in and we'll take a look here. All right, so the input, you see how it just jumps up and it's a flat signal? So that's coming from the USB-C charger. It's just 20 volts. It's just a flat signal, okay? So on the output, we shouldn't have a flat signal because we're pulsing on and off. And so if we measure that, we see a bunch of noise here. And it's actually saying that it's spiking to 20 volts, but the range is around 18 volts is what it says on the output. But remember, we're measuring 6 volts there. But see, this allows us to see a little bit, but this is also measuring all the spikes. But let's measure the gate pin. And the gate pin, we're seeing 20, well, the same voltage actually. So it's almost like it's exactly the same, like these are tied together. So there is a chance that that MOSFET could be internally partially shorted or shorted, and that's what's causing the issue. But so then that pulsing output of voltage that's all dirty is supposed to go through this coil afterwards. So we're measuring the coil input. You see how ugly it is still? But when we measure the output, it should actually be nice and smooth. And a lot of the peaks are gone, but we still have that square wave, and we still have it pulsing, and now it's down to 12.6, so we're actually getting our 12.6 that we were looking for. So this is interesting that this is showing us a little bit more than just a regular voltmeter. And the voltmeter I use is not a high-end one at all. The reason why I use the one that I use is because it can connect to the computer so you can see it. If I had like a fluke, then that would actually probably show a little bit better reading. But anyway, so this is showing us a little bit more here. Let me go ahead and show you what a good board would do. All right, so again, we're going to look here at the input. This one has two MOSFETs here, so it's a little bit different version, but it's basically the same board. So I'm going to measure, so the input's that flat signal, right? It's just 20 volts. The output is dirty, right? But see, it's actually spiking to 20 volts, but it still says 18.2. So it's the same voltage. It's saying it's the same amount. Now let's look at the gate pen. 18.2. So those readings are exactly the same as the other one. So that's why, you know, it's hard to tell if it's the MOSFET that's failing or not, but what we're trying to do is just kind of get clues. You know, we're trying to be detectives and trying to figure out what is wrong and what's causing this. So you see how dirty that is? Now we're going to measure the input of this coil. All right, and then the output of the coil. You see it's flat. You see it's completely smooth and flat. This is what it's supposed to be like on the output of that coil. So we're going to go on the input, dirty. On the output, clean. And then this is measuring at 12.2 volts is what it says it is. Okay, so it's saying a flat, constant 12.2 volts. And then that goes into this chip, and then the gate pin on that one is a constant 16.4 volts. Okay, so it's just letting that voltage come through here, and on the output, it's a flat voltage of 12.2 volts also. Okay, so that's what it's supposed to be doing. This is a good board. So now let's look at our board that we're working on. All right, so the output of that, dirty, but it still says 18.2, the gate pin, 18.2, as I'm pointing at these, the minimum and max there. Into the coil, all right, dirty, but you see those extra little spikes on there, or peaks? And then the output. The peaks are gone, it's still square, but it's not smooth at all. So it's not a flat line across there. And then going into this MOSFET, still pulsing, and then the gate pin on this one. Okay, gate pin still pulsing too. So you remember all this on the other board was completely smooth, clean. And then the output of this is clean. Okay, so we have a clean output, but all of this is dirty. So what is causing it? Now, I don't know. And it's, you know, we're kind of guessing at this point. So I have this MOSFET, and I mean, I don't see how this coil could be bad, but, you know, maybe there's internal winding issue in there. So I would say let's take that off too. Let's get that changed out. I mean, you know, we could start with, you know, maybe changing this one out or taking this one off, but I'm kind of interested to see if we tombstone this and see what the signal looks like on this side, because I want to see if there's any you know, dirty signals on this side, even backfeeding through this or backfeeding through this gate pin into this area. There's also one other MOSFET on the other side of the board on this system, and this one is a low side MOSFET. And if we measure that one, see, we have a dirty signal there, but it's 12.2, and then this is the drain. I mean, this is the gate pin. Gate pin is 5.4. So the low side is this is where it's kind of dumping the extra voltage down. And so that's measuring fine. So all of it's looking fine except for those weird peaks, and then the fact that it's dirty past this. So we can do something really quickly. I'll just lift up this. I'm going to tombstone this. We'll just lift up one side, and then we'll just measure and see what we get different. Okay, so let's go ahead and do that. I'm just going to add a little flux, a little solder, and then we'll lift up that one side. Okay, we got it lifted up and out of the way. All right, so I'm interested to see what the measurements are now that we've lifted that up. There is a chance the power management chip will just shut off everything and won't let anything happen, but I just want to test this. And again, all we're trying to do is just, we're basically being detectives, and we have to kind of work our way through this, try to figure out what's going on. All right, so let's see this pin. So we're getting no signal on there, or are we getting something? Okay, we're getting a pulse. See, it's on, like it's almost like it's testing to see if there's anything going on there. Let's check this one. Same thing. And then this output over here. So it's like it's checking to see if the system's ready to turn on. But what I do see here on this one, do you see how when this pin pulses up, it's clean, it's just a flat line. So it's just applying a straight voltage. What about this one? So it's turning this on, but it's all nice and clean. But this is coming out really dirty. I don't know. I may change this coil out. I've never, we had to replace that coil on that other repair because it got burned up, but I've never seen a coil be bad. And so that'd be interesting if I know this area gets hot, and there's actually no heatsink on this one. The later models, they put a heatsink on this. So that'd be interesting if this coil is actually melted or bad. I highly doubt it, but let's try it. Let's change it out. I have more donor boards. We can pull one off, move it over. So let me do that real quick. All right, let me add a little bit of fresh solder. And see if we can lift it off. Okay, we got it off. Okay, let me grab a donor board. Here we go. Here's one that's the same model. There's one of the same model. So we'll take this coil off of here and get it installed. Okay, I'm going to take this coil off with hot air instead. It's kind of a pain to do it with that soldering iron. I'm going to add some fresh solder because it's having an issue coming off. It might be glued underneath, but okay, we got it off. So here's our new coil. Let's install it back on here. Just like that. I'll just protect this connector real quick. This is the battery connector. All right, that's installed now. All right, moment of truth. Does anyone think that's actually going to work? I'm probably going to say no at this point. I don't know. I've just never seen it be an issue, but I was actually interested to try. So let's figure it out. Let me cool this off real quick. It's hot. It's hot, hot, hot. Ooh, it's hot. Okay. So I am going to plug it in, and then we'll just measure the voltage at that coil with the regular voltmeter. And then if that's wrong, then we'll measure it with our oscilloscope again. So let's go ahead and plug it in. All right, we're still getting the same current draw on the USB-C charger. Let's do our voltmeter on here. What? 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 Do you see that? Oh, wow. Okay. Okay, interesting. We're getting 12.6 volts on here now. Wow. 12.6. Let's look at it with the oscilloscope now. Okay, so going into it, into the coil is dirty. Going out of the coil, clean. A little bit dirty, but then clean. Okay. So we now have the correct voltage on the power rail. Now the question is, does this turn on? Well, I'm saying it probably won't turn on yet. Whenever I plugged in this charger, the motherboard should have turned instantly on. It's saying just 0.03, so I don't know if the board's working yet, but we are getting the main power rail, so we're one step closer to getting this working. So it still say, oh, now we're back down to 5.3 volts. Wait a minute. We just had 12.6. Let me reset this real quick. So unplug it, plug it back in. Okay. We just saw this, right? Didn't we see that there was 12.6 there? Why is it not showing it there now? What changed? I mean, you guys were there with me on this one, so I was very amazed, and you were very amazed. We were all very amazed together. And now it's not doing that anymore. 5.6. Here, I'm going to measure it and plug it in at the same time. So let's watch it. Watch the meter. Okay, ready? 7.81, 8.7, or 8.07. So now we're at 8 volts. Okay, I don't know. That's confusing me. Okay, so let's take a look around a little bit. Actually, let's do the oscilloscope one more time, because I'm interested to see if it's not clean anymore on the output. So dirty. You see this frequency, what it's at right here? I feel like that was higher. Oh, look, now it's dirty on the output again. Interesting. Do you think this coil was hot and it was working fine, and then it cooled off and it stopped working? Or do you think a MOSFET was hot and was working properly and then stopped working? Let's try heating up the area. Ooh, that might be it. Let's do it. Okay, so I'm just going to add some heat here. First, I'm just going to put it straight on the coil itself. Okay, coil's hot. Coil is hot. Okay, so now we're going to plug it in and turn it on. And we're still getting the we're still getting the dirty output. Let me measure it with this. So 5.6. Okay. So we're still getting the same measurement. Okay, so now let me heat up the MOSFET that produces that 12.6. We'll heat that one up. We don't want it too hot because MOSFETs don't work very well when they're hot. But This area does get really hot, and I know that this is, like I said, this one doesn't have a heat sink in that area, so I'm wondering if that could be the cause of this. 5.4, still not doing it. So everyone saw it with me. It had 12.6, and then now it's not doing it. So I have all this hot still. Okay, let me heat up. Let me heat up this other MOSFET that's right here too. There's one other one that we can mess with. Okay. I don't know. I don't know. Is it a... Do we have a capacitor that's bad? Do we have... I mean, you guys got to help me out on this one. This one's throwing me for a loop. All right, next step, I'm just going to change both of those MOSFETs out. Or we'll change first we'll change this one, which is that one that goes from 20 volts on one side and 12.6 on the other side. We'll change that one out first. And then we'll change the other one that's on the output that's supposed to have the clean signal going in, but it's dirty because there might be an internal short on that one. And then if that doesn't work, then I don't know. We're going to have to mess around a little bit more with some other stuff, but let's start by doing that. So I'm going to change out, we'll get under the microscope so I can show you which one we're changing. So we'll change this one first. And if that doesn't work, then we'll change that one next. If that one doesn't work, maybe we'll change this one. If that one doesn't work, then we'll change this one, okay? And then we just know that they're all changed, right? And then we have the power management chips changed, we have that one changed, and if we have all 4 MOSFETs changed out and the coil, what else is there, right? So we're hoping that one of them will do it, but we're going to do one at a time, and that way we can confirm what actually was the fault. So let's get this MOSFET taken off right here. Okay, got that one off. We can actually just test it outside, but there is a chance that because it's doing a high frequency on and off, just me doing a test to see if it's good doesn't necessarily mean that it's going to work at high frequencies, but I'll show you. We tested. I show you this in other videos, so we don't have to spend a lot of time on this, but all right, we're in diode mode. We measure from here to the output, and we got nothing. If we go the other way, we should get a single beep. Okay, and that's on any of these 3 pins because they're tied together. And then if I touch this one with the positive, it will put a positive voltage in there, and then now now the MOSFET will be stuck shorted or on. And then if I put a negative here and then go back, it will turn off again. Okay, so that MOSFET is testing good, but does it work at high frequencies? I don't know. So we're going to replace it, and then we'll continue testing. So I have a donor board here. We're just going to take it off of that because I don't have any of these 6314s, but I have some right here on this donor board. So let me take this one off. All right, here's our new 6314. Got that removed. Let's get it installed on here. All right, we got that one installed. Okay, so what do you think about this? Do you think this is going to fix it? I don't think so. But we have to try, and we're just going to systematically work through all 4 of these MOSFETs and see if we can resolve the issue. You know, if it ends up not being one of those MOSFETs, not that coil, not the power management chip, it's going to be something obscure like a capacitor that's just out of spec a little bit or something. I don't know. And you know, there's only so much time and effort you can do to try to fix one of these motherboards. I just charge a flat rate for labor, and so spending a few hours on something like this does get costly. So, but let this cool off a little bit. We'll go in voltage mode. 5.3. So we're still getting the same. Okay. So that didn't fix it. And if we look through the oscilloscope again, we got our dirty output. All right, so the next one in the line of succession that I'm going to be changing out will be this one, because this pin right here shouldn't be tied to anything else. But yet whenever I measure it, I have a dirty signal here, and if you measure on our test board, it's actually a clean signal. This should just be kind of an on-off, and this one should be a clean signal because it's coming out of here, but we have dirty signals on both of those, so there's a chance that this is partially internally shorted. So let's take this one off and replace it. Okay, we got that one off. Let's grab the donor board and get a new one. So we'll take that one, this one right here. Okay, here's the new one. Actually, one thing I want to test before we continue. So we haven't put that new MOSFET on here yet, but what I want to measure is I want to see what the oscilloscope has now that that chip's off of there. Because remember, if I'm saying it's like partially shorted to the gate and the drain pin. So let's plug it in and test real quick. All right, it's doing that pulsing thing again. So it needs that MOSFET to be on there or else it won't work, but we're gonna measure that pin, the gate pin there. And we're getting nothing on that gate pin. And the output has 4 volts on it. Okay, I was just interested. So, all right, let's install this new MOSFET. Okay, we got that one installed. Do we think this is going to fix it? Probably not. I'm not sure, actually. Let's let it cool off for a second. All right, got the board cooled off. Let's plug it in and test. And what are we measuring? 5.3 again. So I don't know what the fluke was. I mean, we changed out that coil, right? And we got 12.6 right off the bat, which was exactly what we're looking for. And we were pretty astonished. You were there with me on this. And then it stopped doing that, and now we're getting 5.3, which is a different measurement than we had at the beginning. And we were getting 6.5 or whatever it was, right? So why are we getting 5.3 now after we changed that coil? And then we just changed both those MOSFETs. We're still getting the exact same thing. Do we have a dirty output also again? We still have our dirty output on that coil. So I don't know. I don't know what's going on with this one. I'm just gonna have to put this one off to the side and until I'll think about it some more, and then and maybe I'll post this video and just let you guys, maybe someone who's smarter than me can tell me exactly what they think's going on here, because I don't want to sit here and just keep changing out stuff. Yeah, I could change these low sides out. The low sides look like they're fine, but I don't really want to spend that much more time working on this because, it might just be a dead end here. Okay, well, I didn't give up yet. And I was just looking around the board a little bit more, and I don't know if you guys noticed this, but do you see something over here? I don't know how I missed this. I don't know if it was already there. I don't know if this happened later. But there's our problem. This is... it's pretty ridiculous. So we have this capacitor that's cracked, and we have whatever this thing is, and we have that thing, whatever that thing is. That looks like a little ceramic capacitor. That's like a tantalum or electrolytic. And this is, I'm not sure. So we went down a whole rabbit hole, and we should have done our physical inspection. And this is what always drives me crazy, is I start thinking about one thing and I don't go through and do the physical inspection. And I know the first thing Louis Rossmann would say is to do a physical inspection. So I'm very sorry that I did not do that and wasted everyone's time. But now whether this is fixable or not, I don't know. We don't know why this burned up. But it definitely was a pop or explosion. You can see these carbon gases coming out here to the side. So we're going to try to get these components off of here. We're going to get this whole area cleaned up. We have our donor board. We'll put some new parts on here, and then we'll continue testing. And I guess this might make sense why it worked for a few minutes, or it worked for a little bit when we changed this out. You remember we got the 12.6 and then we were amazed and then it went away. So that must be the issue. It must have been something intermittent there. So let me take this heatsink off and we'll get that stuff changed out. Okay, I'm going to protect this keyboard connector, and I'm not sure, you know, this one right here looks like it might be welded to the board. When it melts like this or gets really hot, it usually will weld itself to the pad, so we got to be very careful with getting that off, or else we might damage the motherboard. Oh, the motherboard's probably already damaged, but we're going to do our best here. So I'll try to put enough flux here. We're going to add probably some solder. I need to get this moving around before I just start applying heat to it. Okay, yeah, we got one side off pretty good. I'm gonna try to be careful. This is like a big weld blob. Okay, just gonna add some more solder right here, and then we'll probably switch to the hot air. This is going to be the problem one right here. And we are right next to that keyboard connector, so we're going to try to blow the hot air away from it. I'm going to add another pad on top of that. And the chipset's right here too. You don't want the chipset to get hot. Okay, so let's get this one off. Okay, that one's off. That's good. What about this one? That one's good. Can we get this off? Hey, it came off. Nice. All right. Let's get all this old solder taken off of here. Let's clean it up and see how it looks. It looks better than I thought it was going to look, so that is very good. So we'll need these three components, and let's see what those components were. They were so damaged we couldn't really tell. And so here's our donor board. Oh, an inductor. So this is an inductor, capacitor, and another capacitor. So electrolytic capacitor, ceramic capacitor, and an inductor. An inductor is just like a coil like this. This is just a smaller one here. It smooths out signals. So that may make sense why we were getting kind of that dirty signal there. Assuming that this is all tied over here somewhere. I don't know this. But so let's get these taken off. Actually, I'm going to put fresh solder on this first, so that way we can just take them off and transfer them straight over. we have an issue on the board here? Ooh, a little bit of a burn there in the middle. But I think we're okay. It looks like there's a little bit of a burn, but the pads are still intact. So we'll be fine. Let's put fresh solder on these pads, and then we will transfer those components over, and then we can test. All right, let me move one component over at a time. All right, so these are the components we're going to take off. First one, second one, third one. All right, we got them all off. And let's get those new ones installed. Clean up these solder joints. All right, we got all three of those new components installed in that burnt area that we missed, and we went down a rabbit hole for no reason. Lesson learned. It's funny because I know to always look over a board, and I usually do, but for some reason I was like, I'm going straight to this. I know what it is, and you never know. So. All right, we'll get this cleaned up. Everything looks good there. Okay, moment of truth. Do you think this is going to work? And I actually think this will work. Those other chips we changed out, I didn't really have high hopes that it was actually going to fix it, besides the power management chip, because that's actually a common issue. But having a obviously burnt component, that would make sense. Okay, we're going to plug it in. We'll check our main power rail. 5.7. Is that correct? What do you think? No? I don't think it's correct. 5.7 is no. And then we're going to check the output again, and we have the dirty output. So here's where I'm at on this issue. I'm going to change the power management chip one more time because I have a feeling that burned out the power management chip again, or damaged something over here. So we're going to switch that out one more time, which is annoying because these things are about $8 a piece. But you have to do what you got to do. So let's go ahead and switch out the power management chip again. All right, change out the power management chip for the second time, so let's see if that works. I'm thinking that there is a chance that those burnt chips cause damage to the power management chip after the fact. So let's plug this back in, take our measurements. All right, look, it's actually turning on and it's pulling amps now. The power management chip definitely did get damaged again, so let's measure the main power rail, and we got our 12.6. All right, so looks like a combination of things happened. We did go down kind of a rabbit hole, but we ended up in the same place we started. We changed out the power management chip first, and then we went and started changing out the coil because we were getting that dirty signal. We changed out the couple MOSFETs, and then we noticed that whole burnt area there. at one point we did get that 12.6 that we were looking for, and I didn't really understand why that had come and then gone again. But now I can kind of see that that burnt area probably sent voltage the way it needed to go for a second, and then ended up shutting it off or something like that, and then burned out the power management chip all over again. So we went through 2 power management chips. These things are about like $8 a piece, so we're like $16 in parts, which I just charge a flat rate for labor. It includes all the parts and stuff like that. So and I spent a good amount of time. We're at almost 2 hours of recording time here. So all right, let's go ahead and get this installed, and let's test it, make sure it's working. All right, I got the motherboard installed. It's the moment of truth here. Let's turn it on, boot it up, and see if it actually is working. See if we actually repaired this motherboard. This was an interesting repair. I almost gave up. Pulling amps, we got our Dell screen. We got 2.28 amps being pulled out of the charger. Got the Dell screen. It's a good sign. Let's see if it gets past this Dell screen right here. It is going to take a little bit longer because we pulled the motherboard out, so it's doing a CMOS reset, so that takes a little bit longer on the first one. We got about 4 amps coming out of the charger now. And is it going to turn back on? And the screen went dim. All right. It's booting into a diagnostic. It's testing the processor fan, testing the video, the GPU fan. Okay, so the keyboard's not working. Let me check the connection real quick. Ah, I didn't latch it all the way. All right, keyboard latch is in. Let's try again. All right, keyboard's working correctly now. Let's boot into diagnostics real quick. All right, excellent. Let me brighten this up for you so you can see. Got the battery is charging. So we have 130 watt charger being detected, showing charging, 2.8 amps going in. Battery was at 74% at 75%. So it's charging the battery. It's running the system. If I unplug it, it's running off the battery just fine. So we got this laptop fixed up. This was an interesting one. I would love to know your thoughts. Just let me know. And hey, thanks for watching.
I saved another laptop!